is all about a Kaggle data science survey that was given to Kaggle participants. And today we're going to be analyzing the data and taking a look at what people said their most common programming languages were, what their experience level is, and what their compensation is in their roles. So as we get started, hello, my name is Anna Strahl, and I am a senior course developer for Dataquest. Before I worked for Dataquest, I started my career as a high school and middle school math teacher, and I did that for 8 years. And then I transitioned into working as a data analyst for 3 years, and I was self-taught, and I actually used Dataquest materials to help me learn the skills I needed to become a data analyst. So if you are looking to make a career change, my story hopefully can be a little bit of inspiration for you. And now I get to do the best of both worlds. I get to teach and do data analysis as a course developer here at Dataquest. So who are you? I want to make sure that this webinar is valuable for everybody who's joining. And this webinar is going to be focused more on beginner-friendly Python. So having some familiarity with lists, loops, and conditional logic. If you know those things, you're going to be able to follow along with 95% of what we covered today. If you've never worked with importing modules or libraries, or you've never worked with matplotlib, we're going to have some cool moments where we work with those things. But if you haven't worked with them, it's still going to feel approachable. And if you are beyond this level, I am trying to make the webinar valuable for everybody, but just know that it might be a little more beginner friendly than you're looking for. So I do want to make sure we're honoring everyone's time. So I want to quickly start with a poll to see what our audience is like today. So I just launched a poll with 2 questions. The first one is asking what your experience is with projects, and the next one is more specific to Jupyter, because I want to know how much I should focus on the ins and outs of Jupyter. And while those responses are rolling in, let me address a couple questions I get often in these webinars. This webinar is being recorded, and the recording will be shared out tomorrow via email. So everything that's happening right now, you can replay at your convenience after tomorrow. And if you have questions for me, please use the Q&A box. I see a few people trying to raise their hands. The best way to ask me a question is to use that Q&A box. All right, let's go ahead. If you're pondering your solution or your answers for the poll, get those in quickly, and I'm going to end the poll shortly. Okay, so let's take a peek at the results. So it looks like in general, people have done a couple projects, but nothing serious, which I think this is a great project to have that level, because there are a lot of places you can take this project after today's walkthrough to expand it and potentially add it to a portfolio. And as far as Jupyter experience, the basics in general, that's great. And if you're one of the folks that says you've never used Jupyter before, some of what we're doing today might feel confusing. So I'll try to add in a couple things that make sure you can use the interface that we're using together. All right, thank you everybody for answering that poll. It helps me make the webinar as valuable as possible to everybody. All right, so what are we doing today? We're going to talk about the project. We are going to load in the data, do a little bit of cleaning, doing some counting and aggregating of the data. And just for fun, we're going to add in some visualizations. And finally, we will end with Q&A. So if you do have questions for me, know that I will see them, but I'll address them closer to the end of the webinar, just to keep our workflow smooth. And this is the question we get a lot in these project walkthroughs. So I wanted to address it right off the bat. A brief note about AI. The question we get is, why do this project by hand if AI can do it faster? And it's a valid question. AI is very prominent, especially in coding. But if you are a beginner or even intermediate to a programming language, practicing the fundamentals is essential. And the reason for that is it's kind of like asking, well, why read the book if the movie exists? Well, it does different things for you. First of all, reading is really good for you. Do you know how to read? If so, then the book can be really valuable. And the same thing is, excuse me. The same thing is true with the fundamentals of programming. You need to know them. Debugging, the second bullet point, debugging is really, really important. And AI gets it wrong sometimes. And if you don't know where AI got the code incorrect, you're not gonna know how to move forward. So projects like this in particular that help you develop these skills without using AI, or at least not relying on AI, is a very, very valuable thing to practice at this level. And finally, this bullet point at the end, doing the project by hand ensures that you are developing a deep understanding of the project. And that's valuable for interviews. If you let AI do the project for you, I don't think an interviewer is going to be impressed if you say, well, the AI did the work and I'm just presenting it. So you want to say where you got stuck, what you were excited about, what you learned. So that is the AI note. And now let's continue. Okay, so in this project, we are going to take on the role of data analysts for Kaggle. And if you're not familiar with Kaggle, it is a very, very great website to be familiar with if you're working in the data world. It is a place where people share data sets. There are competitions for data science, and there are cash prizes. So if you want to have some incentive to really practice your data science skills, Kaggle is a great resource. So they did a survey for data scientists and asked them several questions about their careers. And our goal in this particular project is to look at the data and see what skills are important for data science and what are the kind of compensation or salary expectations that people can anticipate for different levels of experience. So at this point, let's jump into the app. And here we see our Jupyter environment. And to get started here, I'm going to copy and paste from the gist that was shared out in the chat message. And this gist code does vary slightly from the official solution code that's part of the project. And I'll explain where the deviations are. Okay, so our first thing that we're going to do to get started with our data set is we're not using pandas for this project. This is a panda-free, beginner-friendly project. So instead, the way we're going to read in our data set is using the CSV module. And we're using a width chunk in order to keep all of it's called a context manager. And it ensures that your open function doesn't stay open. It closes when it's finished, which can help just for security and potentially also help with just the speed at which code runs. So we're opening our CSV file, and then we are storing the read version into a variable named reader. It's sort of like if you grab a book, you open the book, and then you read the book. And then our final thing is we're taking the reading we're doing and turning it into a list. And this list is what our official variable data set name will be for the remainder of this project. And because we're storing it as a list of lists, where each list inside the list represents one row. We're going to pull out the first row, which is the column names, and then have just the survey responses be everything else. And we're going to take a peek at this. If you joined me for one of these webinars before, you know I really enjoy looking at the, like, just visually seeing what my code's doing after each step to make sure it's running how I think it should. So we're going to print the column name variable, and then add a space here just to make it a little clearer that this is a separate thing. We are going to take a little peek at a couple rows of our survey responses. So for row in range, and I just kind of picked range values here that would give me a small slice, because if we tried to just print all of this, it has over 2,000 rows, and Jupyter and your computer will not be happy with that. So just looking at a small section will do what we need it to do. And so for every row in this range, we're going to print the row. And for those new to Jupyter, this is a coding cell. If we press play, or I use Shift Enter on my keyboard as a shortcut, it's going to render everything that we just wrote. And we can see here, we have our column names printed. And then we have 5 survey response rows printed. And the first thing I'm seeing is everything is stored as a string. And that's because we read it in. If you wanted to do this project with pandas, I think that'd be a really cool way to convert this project and test your knowledge of pandas. Pandas will do this data typing automatically. So before we continue, we need to address this. And here's what we're going to do. This is going to look like a lot of code, but it's all part of one loop. And here's what we're doing. First of all, we are creating a variable that is a count of the number of rows in our data set. And the reason we're doing this is so that we can use that same range function again. And let me explain that briefly. The range function is a function that's built into Python, and it is a count of numbers from here to here. And so by giving it just one number, it's going to say starting from the very beginning and going all the way up to this number. And now within our loop, we're going to convert. So this first value in each row is a number, and it's a decimal number, which is a float. So we are going to reassign the first value. And for I, this means for a row in our data set, we're going to reassign the first value to a float of whatever the existing value is. And that should successfully convert this. The next one, true and false. We don't want these as strings because they would be much better served as Boolean values. And so for Python user, for example, if the value of the cell is set to the string of capital true, we're going to reassign it to true. And notice how the text color changes here. That's because this is the string version, this is the Boolean value version. And if it's not equal to this, we're going to set it equal to false. Quick note here, we're not accounting for any blank or missing data. And if you were completing this project on your own from scratch, that would 100% be something you should account for. However, I know that there aren't any missing values, so we don't need to account for that. So everything is either true or false. We're not going to need missing. So we're doing the same string to Boolean conversion for Python user variable, for the R user variable, if we look at our print statement here, and then also for our SQL user variable. All of those should be Boolean values. And these code comments are really helpful because in a long loop like this, especially when we're working with list indexing instead of pandas where everything can be referenced by name, this can really help your future self and any audience you share this with understand what each condition is checking. All right, and then most used. The most used is if there's a particular subtool or library module, if it's Python, that is most used. And some people said none, and none can be converted into a special like Python keyword here. So we're converting any none strings into none keyword. All right, and then the final one we're converting in our data cleaning step is the compensation or salary. We are converting from a string into an integer. And we'll go ahead and run this. And let's peek to make sure everything is converted now. So you'll notice we're printing the column names just to keep things, you know, a little clearer as we check our work. And for every row in the range, we're going to print the row. And let's do a quick comparison here. We have 6.1 compared to the string of 6.1. Instead of true, true, or true, false, true, notice now that there are no string quotation marks around it. And the final one we changed, changing the compensation to an integer. Once again, we see the string quotation marks are no longer around it. So we can feel fairly confident at this point that our data is in the correct format for further analysis. Okay, next section. So the first big question we're going to ask ourselves is how many people use each of these tools? So we have Python, we have R, and we have SQL that we're being asked about in this survey. And to get us started, I see Jean or Jean in chat asked to the hosts, do you have to reproduce what we're doing? If you want to just watch and listen, you are more than welcome to, but you do have all of the tools available to follow along locally if you choose to. The code that I'm copying and pasting is from a GitHub gist that you can copy and paste on your own, or you can manually type the code if you want. Whatever you think is going to be most valuable for you to learn from. All right. And I'll address it. Yes, this is being recorded and it will be sent to everybody tomorrow. Okay, so what we're going to do to get a count of everything for our different programming tools is we're going to initialize 3 variables set to 0. So we're going to start with Python as 0, R as 0, and SQL as 0. And then for I in range, this is pretty familiar at this point. So I is a pretty common way to refer to things in iterations. I think the I stands for iterable. But if it's easier for you to understand, you could change this to the word row and say for row in range. But you would need to make sure anywhere there's an I here, you change that to row as well. So for every row in our data set, if the Python associated value is true, and notice that we're not specifying the word true here. And this is because conditionals are looking to evaluate to true. So if that's what we're looking for, we don't need to say true, it's already assumed. So if the Python value, then we're going to add 1 to our Python count. If the R value, we're going to add 1 to our R count. And we could be fancy here if we wanted to, for example. and do a plus equals, because we're just adding one, which is the same thing as keeping the value and adding one. Your choice. And then the same thing for the SQL, excuse me, SQL column. If there's a value of true, we're going to add 1. So hopefully, if we've done this correctly, these values will now have something other than 0 associated with them. So I'm going to run this cell, and we don't see any output because we didn't ask to display or print anything. So just very quickly, I'm going to look to see if one of our variables has a non-zero value associated with it. And this is a Jupyter trick. Whatever the final displayable thing is in a cell, you don't need to include a print statement. It's going to automatically display it. Whereas, for example, if we have 2 variables like this listed, it's only going to display the last thing in the cell. So we don't get that Python count anymore. So if we want to display more than one thing, we have to use a function to tell it to display. Okay, so because notebooks are a very good way for presenting data and presenting projects to end users, we are now going to display all of our counts in a human readable, digestible way. And this is another place where it deviates slightly from the official solution code, because actually, here's the official solution code that is accompanying this project. And look at how much kind of repetitive text is needed here. It's fine, it does the job. But I thought it could be cleaned up. So we're using a dictionary, and we're storing in the dictionary the key is the language, and the value is the count. And here's a very fancy loop. If this is beyond beginner level, don't worry. Feel free to stick with this slightly more repetitive basic version. It's absolutely okay. But what we're doing in this loop is we are doing 2 things at once. For language and count in usercounts.items. And .items is a dictionary-specific method that pulls key value pairs into a tuple. And tuples are sort of like lists, but they use parentheses instead. And that's why we can use 2 variables in our for statement here. And so now, look at this. We're using an F string, which stands for formatted strings. And I really love F strings compared to, let's look at the official solution again, having to use plus signs and string conversions for non-string values. String formatting, all you do is before your string, you put the letter F. And then for anything that isn't directly a string, like for example, if we want to add a variable in, we can use curly brackets. So language corresponds with this variable value. Count corresponds with this variable value. And we close the string. And this will automatically update this sentence or phrase for each of the variables. And same thing, so we're going to say the number of whatever the language users, give the count, and the proportion of language users. And here we can even calculate within a format string value. So we're going to divide the count by the number of rows to give us the proportion. And look at this, much less typing of repetitive things to get our values here. And it looks like at a glance, Python is by far the most popular response in this data science survey. SQL is next most popular, and then R holding strong at about 5,300. And we can see that with the proportion as well. Okay, so the next thing we're going to do, now that we've kind of gotten a rough count of all of our programming languages, is we are going to look at what is people's experience levels in years and compensation amount for the data science job they have. And by the way, I'll take a pause here. This is a question I often get. Why am I not adding in markdown cells with titles and stuff? It's honestly just to try to get through as much of the coding as possible in these walkthroughs. So if you are to use this project and share it with others, I highly recommend adding in markdown cells to explain new sections of code using headings or subheadings. All right, so do as I say, not as I do. Okay, so we do have a couple comments helping us out though. So this comment is telling us we're going to aggregate all the years of experience and compensation together into a single list. And we are initializing two empty lists. The first empty list is for our experience level, and the second empty list is our compensation level. If you are using pandas, this is not a step you need to take, because pandas, you can pull a column of values just from the get-go because it's stored as a data frame. But because we're using lists and all of the experience levels are stored in a particular spot in the list, if we want to calculate on just these values, there isn't an easy way to do it. So we're going to pull everything into its own list. So for I in range, or for row in range, if you so choose, we are going to append or add slices like of the specific information we need to each corresponding empty list we created. So I'm going to scroll back up. And if we look at, here we go. If we look at our row, we can see that the experience corresponds with the very first value in a list. And Python is 0 indexed, so this first value is actually the 0 value. And then for compensation, if we count 0, 1, 2, 3, 4, 5. So this should be number 5 to get the compensation. So 0 for the experience and 5 for the compensation. So it's going to iterate through, add all those values into our new lists here, and then I'm printing a small slice just to make sure everything worked the way I want it to. This is a very good debugging step because we can tell immediately that experience levels and compensation values are correct. It's very, very common, especially when newer to indexing, to miscount. And we would very quickly see if we printed that this is not the correct compensation value. These aren't compensations. So we'd want to check our code here. Okay, so now that we know we have a list of experience and a list of compensation, we can more easily pull out some kind of summary statistics about them. So we're going to start with the experience list, and we're going to find the minimum value. So what's the smallest experience level in the survey, the maximum value, and the sum divided by rows to give us our average value. And finally, to kind of display this, using some F strings here to print each of these things. Randall, your Jupyter server stopped running. If you're using Dataquest, if you click refresh or refresh your browser page, it should come back and keep your work stored. Okay, so looking at our statistic values here, minimum years of experience is 0. That makes sense. You know, a brand new data scientist doesn't have any experience yet. They answer the survey, 0 is the value. Maximum years is 30. So someone very experienced with data science has been doing this for 30 years. And then our average, a little more than 5 years. But I think we can do better than just looking at the raw number statistics here. So here's once again where my code deviates from the official solution code, because we're going to plot. If you're new to plotting, I made this very beginner friendly. If you're not new to plotting, make your plots prettier than this. This is the most basic way I could display, okay? So to visualize, we're going to use a library called matplotlib. And we have to use the .pyplot kind of like submodule. And because this is a really long name, we're going to give it an alias or a nickname as PLT. This is the kind of standard. Because we're working in Jupyter specifically, this line of code is required to make sure our graphs render how we want them to. And then here's how we make a graph. We're going to create a histogram of our experience coding column. And then we're going to show it. That's all you need to display this visually. Ta-da! And look at this great histogram. And I think this is so much more robust than just looking at the raw summary statistics here, because we can see that it's really skewed. The majority of people have 0 to 5, you know, maybe up to 10, but more experience levels than that are pretty minimal in this data set. So now that we've looked at experience and kind of gotten an idea of what people responded with in the survey, we're going to move on to compensation. A very similar code here where we're doing a min, so minimum value, maximum value, and the sum divided by the number of rows for our average. And for our print statements using f strings with our curly braces, but I added in a little bit of flair here, where average compensation is going to render as a float. And because it's an average, actually, I'm going to delete this and I'll add it back so you can see what the kind of raw value is. Okay, so look at this. The average is this crazy long decimal, kind of ugly to read. And because we're talking about money, it's very common to round money to 2 decimal places. So built-in Python function, you don't need to import anything. We're going to round it to 2 decimal places. And all of this is happening within our f string, which is just so satisfying. And now it's a lot cleaner to look at. So minimum compensation is 0. Maybe they're an intern, I'm not sure. Maximum compensation, $1.5 million. That's unusual, I think. But we're going to visualize to confirm or deny if this is unusual, because the average is about 53,000. So let's visualize this in a histogram, very similar to what we were doing before. PLT, we don't need to re-import it because it's already stored in our notebook. PLT.hist for histogram, and then we take our compensation list and show it. Well, that's an unusual histogram because almost all the values we can see are very much on the left here, and the values get so large that it's trying to render them in scientific notation for us. So next steps in this project, I think it'd be really cool to clean this data and investigate whether or not this is an outlier or not. because if it is an outlier, it's going to be kind of messing up our average here. So that's my challenge to you. It's beyond the scope of our time together, but I challenge you to clean this data and investigate this a little bit more. Okay, so what we're going to do now is we are going to visualize our experience in tandem with compensation. So is it more likely to get better compensation the more experience you have? And to do this, we are going to add a new value to each row in our data set. So for I in range, if the first value, which corresponds with the experience level, if the experience is less than 5, we're going to add a value to that row that says they have less than 5 years of experience. If they have more than 5 years of experience, but less than 10, we're going to add at the very end of the row a value that says between 5 and 10. And same thing for 10 to 15, 15 to 20, 20 to 25, and then kind of a bucket at the end for people who have more experience. We do know from our prior investigation that our maximum value is 30, so we could cap it, but this just is a little more flexible to leave it open-ended like this. Are the buckets perfect? No, because technically we are not including 10 here, but the label says 10. So you may want to make these labels a little bit better, if I'm being honest. Maybe say 5 to 9.99. See the problem there? So if you are presenting this to an end user, I would make sure that you add a note explaining the labels you picked, just to make sure the data is not being misrepresented. Okay, so we are running this loop. Let's take a quick peek at our data. I'm going to steal this. And just see if things added successfully. Okay, so we're printing our survey responses again after adding in that extra value. And we can see that, yes, there is a new value. The column names have not updated to match because we haven't added anything to the column names list. So 6.1 years of experience does have the correct bucket. 12.3 does have the correct bucket. 2.2, 2.7. So we can feel pretty confident that our list logic here worked as we expected it to. Okay, so the next thing we're doing is we're going to create some bins. And we're manually creating some empty lists of bins for our different values. And the reason we're doing this is we are going to add our compensation values to these bins, so we can get the average compensation for each of these experience levels. So for I in range, if that new value we've added to the row is less than 5 years of experience, we're going to add to our 0 to 5 bin, not the experience level. We are adding the compensation value, which corresponds with the 5th element of that list. All right. Going through and doing the same thing for each of our bins. And I'm not going to run this because, or I'm not going to display because it'll be really, really hard to look at. But we're going to run this cell, and then to display, we're going to use our print statements and check the length of each of our new bin lists. Notice that this is not an F string. And the reason I left it as a kind of regular string with the plus and string is to give you some homework. If you want to convert it to an F string, which I encourage you to do, here's your opportunity. This could look a little bit cleaner if you used an F string. But let's go ahead and render it. Take a look. Okay, so just kind of going off of gut intuition here, this makes sense. The largest value is with our lowest level of experience bucket, and the smallest values are our highest levels of experience. But I think we can do better. Let's visualize this. So to visualize this, because we have labels that we want to include, we're not going to be able to use a histogram with just a single list like we did earlier with the visualizations. So instead, we're going to create a list of labels called bar labels, and then a list of our experience counts. And len is the built-in Python function for length. So we're taking the length of each of our bin variables, and let's just quickly print to make sure everything rendered. Yes. So do you see how this experience count list corresponds with these values? So far, so good. And now what we're going to do, slightly fancier graph. We're adding a couple extra things. This time we're using a bar graph, and our X values, just like an ordered pair from plotting graphs, X and then Y alphabetically. So X axis is our bar labels, and our Y axis will be our experience counts. In matplotlib.pyplot, title is the title, X label is your X axis label, and Y label is your Y axis label. And we're going to just add those in as strings and show our plot. And we can see very, very left skewed years of experience, much easier to digest than just reading this printed output. All right, looking at our time, yeah, we're doing good. We're doing good. So now that we're kind of familiar with the distribution of years of experience, the final question we want to ask is, what are the salaries? What are the salaries associated with each of these buckets? Okay, and this code is going to look kind of text heavy, but we'll talk about it. Excuse me. So I made a variable for each average. And for each average, averages are sum divided by the count. So we're summing the bin list associated with that experience bracket, dividing it by the length of that list. And then for some, excuse me, for some visualization stuff in a moment, we're creating a list of those averages. And then we are printing the averages out using F strings. Okay, so we can see the average salary of people with less than 5 years of experience, about 45,000. And homework for everybody to make these money values look nicer, consider adding in the round function and rounding it to 2 decimal places. In fact, the decimal, like the cents aren't even that important for this analysis. So if you wanted to round it to the nearest whole, that'd be okay too. So far looking all right, but let's visualize this. And this is the fanciest visual we're gonna do. We are once again creating a bar chart, and our x-axis will be our bar labels. And our bar labels, remember, is the list we created here. We're going to reuse it for this next bar graph. And our y-axis values will be our salary averages, which we stored in a list here. We have a title, x-axis label, a y-axis label, and this is the fanciest matplotlib method that we're using. If this one is kind of like overwhelming, don't worry about this. You do not need to include it. So actually, let's comment it out and take a peek at the graph. So a nice looking bar chart. Kenneth, you're correct. Yes, f-strings have formatting ability to round, and I encourage you to do that. So nice looking bar chart. Yes, keeping it under 25 years of experience. Yeah, slightly higher salaries here. But what does this mystery line of code do? Let's take a look. Adds a dotted line. Ooh, and this dotted line represents the overall average compensation level. So just to explain it a little bit, AXH line is a way to add a horizontal line to your axis. You can change the line style. I like a dotted line myself because it kind of makes it clear it's not part of the actual bars. It's just a little bit of extra information. Change the color to make it separate. And the label here, actually, I was experimenting. That part is not correct. So delete that, please. And now I think it gives us a little bit more information. Side note, if you're presenting this or sharing this yourself, I would highly recommend adding an explanation of what this dotted line means, because right now it's not immediately obvious. So it is interesting though. Look at this. In general, the more experience you have, your salary goes up, but it's not linear. So maybe that's due to some outliers. Remember, we had that one like $1.4 million salary. So maybe that's influencing something here. But it is interesting to see that the average overall salary is only completely higher than the lowest experience bracket, which tells me that there is a lot of people in this lowest experience bracket. And that's kind of like pulling the overall average down a little bit. But once again, cleaning the data and maybe eliminating any outliers would be a very good way to make this analysis more thorough. So that is the end of our walkthrough. At this point, we've got about 10 scheduled minutes for questions. So if you have a question about anything here, please go ahead and ask me in the Q&A, and I will work on those. But if you want some ideas for next steps for this project, let's say you really like this data set, you like the kinds of questions you get to ask with it. Maybe you're trying to be a data scientist and you want to know, like, what is this survey telling you? Here are some more ideas for you. Do certain programming languages have higher salaries? We looked at overall salaries, but what happens when you break that down to Python or SQL or R? What about the most used libraries variable? Are people who use TensorFlow getting higher salaries than people who use scikit-learn? I don't know. What about, are people who know more than one language more likely to have higher salaries? What about years of experience? So if you say you know Python and SQL, what's your salary compared to someone who only knows Python or only knows SQL? What are the most common skills used? So if you are looking to become a data scientist, what are some of those skills that people said were important to them? And this data set was, I believe, from 2021. And I bet that you could now find a data set that's similar to this from 2023 or 2024. Maybe not 2024 yet, depending on when Kaggle releases these surveys. But are the results similar, different? What's changed? So some fun next steps for you. Okay, so now let's look at the Q&A. Okay, Jean asks, please, oh, we answered that, to reproduce what we're doing. So we've been sharing my solution code in the chat, which leads to a gist from GitHub. So If that's valuable to you, take a look at it, try to run it on your own, try to understand the code. Or if you did want to code along, I hope that was fun too. Okay, and Jean asks again, why don't you just use the read CSV function? That would make this a lot easier. This project is designed for beginners who have not yet learned pandas. So if you know pandas and you know read CSV and you know value counts and all those things, I do challenge you to convert this project from lists of lists into a pandas data frame, and practice your pandas skills. I personally do think that there's a lot of value to be had from practicing with these basic Python skills and really refamiliarizing yourself with lists and list indexing and manipulating lists to work with data. But yes, you could use read CSV if you are familiar with it. Someone asked, as a beginner in Python, how do I really navigate this? That's a great question, because I know that I went quickly through a lot of code. My recommendation is to go one cell at a time and see what you understand and what you don't. So for example, if we're starting with this very first part of the code, maybe you're not familiar with import CSV. And here, remember at the beginning of the webinar, I talked about AI. Here is how I think AI can be helpful for beginners. I recommend opening up Chandra and taking whatever line of code you have. My screen is magnified right now for webinar purposes, but things do look a little nicer in a non-magnified way. And take whatever code it is you need help understanding and say, please explain this code to me. And you can kind of get a teacher in the AI to tell you what's happening. And if the explanation doesn't make sense, this line imports the CSV module, clarify, say something like, what is the CSV module? And you'll get a lot of information about it. So how do you navigate this? One cell at a time, one line at a time. I'll be honest, like when I was a beginner learning projects like this, I spent so much time learning each specific line by Googling. Stack Overflow, Stack Exchange were my best friends. They still are, if I'm being honest. So I, I don't necessarily have this stored in my brain. So do a little bit of research if you need to figure it out, right? And as far as navigating, this is my other big hack for navigating as you go through a project like this. Print out every single thing you are doing. For your final like the version you're sharing with others, maybe take these print statements out, because they're mostly for you for debugging purposes, but visually see what's happening. And then you're going to have a lot better idea of like how what you're doing is impacting something behind your computer screen. And as a reminder, if you have questions for me, please use the Q&A box, just because the webinar chat box moves really quickly. Okay, Narun asks, how to do projects related to project management. So recruiters will look at your profile. Okay, so if you have a specific area of interest, like project management, I do highly recommend going onto Kaggle. What is it? Kaggle.com, kaggle.org. Let me check it out for you. Kaggle.com. And I'll pop that over here actually. And looking at their data sets. Find a data set related to your interest and download it and see from whatever variables there are, what questions come into your head. And then go through your data process, clean the data, analyze the data, visualize the data. If you want to use machine learning or deep learning, add those in. And then you have a data set related to your interests. You have a project related to your interests, and you can upload it to GitHub to share with recruiters. That would be my advice there. Okay, what's my advice for learning Python? Practice, 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 practice. It's a language, and just like any language that you're trying to learn, you need practice to become fluent. So if you've taken a Dataquest lesson on lists, now it's time to practice lists. Practice through projects. That's why I like these beginner-friendly projects, because by the end of this project, you should be very, very comfortable with lists and referencing by list index. And not only are you doing a lot of list work, you're doing it in a context that is like actually applicable for a data analyst or a data scientist. And Jennifer asks, can I talk about how practice data sets will differ from those we might be working with in the industry? So if you take a peek at Dataquest projects in general, often the data sets are real data sets that have errors, they have missing data, they have outliers. Usually for beginner-friendly projects like this one, it is real data, but we clean a little bit for you because we don't assume that beginners have the cleaning experience needed. So as far as how it'll differ for data sets you might use in the industry, it's pretty similar, if I'm being honest. Industry depends. For example, I was a data analyst for counting homelessness data in my city. And that was really, really messy data because there were a lot of null values and incorrect values. So I would say that was like different because of how messy the data was. But yeah, I think it's really industry specific there. HMIS data, yes, Dave. Yeah, data cleaning was probably 90% of my work at that job. Tom asked, oh, actually, I'm going to pause before I address Tom's question. We are technically at time, so I want to honor everyone's time and thank you for coming if you have to hop off. This will be recorded and sent out tomorrow. But if you do want to hang out a little longer for Q&A, I'm going to stick around for 10 more minutes. And any question that has already come in, I will work on addressing. So I just wanted to pause and say, if you do need to run, I understand, and I want to honor your time. Okay. Okay, so now diving back into a little more Q&A. So Tom asks, would a good next step be to do a linear regression and predict salary based on years of experience? Yeah, that sounds like a really, really cool next step. And if you do that, Tom, please share it in the Dataquest community and tag me, because I want to see it. Where do you download the data set? An anonymous attendee asks. So where do you download the data set? So this particular data set you can download right here. And I think I did see a question in the chat box that I'll break my rule and say I'll answer here. If you didn't want to use Python, you could do this in Excel or Google Sheets, but it has a lot of downsides associated with it. The first one being reproducibility. You lose a lot of the granular step-by-step if you do things in Excel or Google Sheets, whereas in Python, you can see every single step you've done to clean, to process, to analyze. So for reproducibility and visibility, I think Python's better. But for downloading the data set, if you use right click, you can download this data set and work with it however you want to. Any resources from Dataquest on SQL and Python? Yes, we have a couple lessons on using SQL from Python. I don't remember off the top of my head what they are called, but I can find that for you. One moment. I'm on my side monitor here. I want to say, actually, I think I know the number of the lesson. Let me see. No, that's not it. That's not it. Joshua, I like your print statement. Thank you. Very fun. Okay. Okay, so in the data scientist with Python path on the Dataquest platform, in part 5, which is working with data sources using SQL, there is a section called querying databases with SQL and Python. And I'll share the link to that lesson in chat right now. Okay, Tamirez asks, with your experience in data analysis, do you think Python is the best tool, or would you learn other tools to complement it? Which tools do you think complement each other? So when I was first starting out, I thought I had to learn everything. I started learning Python, I started learning R, I started learning SQL, and it was very overwhelming. And I think if I were to give my past self some advice, I would say stick with Python and SQL. Python or R, but I'm assuming if you're in this webinar, you're doing Python. But look at your industry, look at some job postings from whatever industries you are interested in, and see whether or not more listings have a requirement of Python or R. Because some industries do use R more frequently. And you know, it's not an either or, but it kind of is on those two. SQL is universally useful, and a lot of data analysis jobs prioritize SQL a lot. And in my opinion, SQL is a little easier to learn because the syntax in general is a lot closer to how we speak. So yeah, I would keep SQL in your programming language repertoire for sure, and one other main language. When you work on a data set, how to know you're on the right way? That's the question. That's you know, where the art of analysis comes in. I think that there is not one for sure way to know that what you're doing is the best way or the right way. But I think always asking yourself if it makes sense and is anything possibly being misrepresented or skewed will make sure that your analysis is not misleading. And then also getting feedback. Getting feedback is very, very important because if something you've done is incorrect and you're kind of like blind to it because you've been looking at it so much, getting feedback from someone else will really, really help. And on that, I'll plug the Dataquest community. Because community is very good for getting feedback and kind of making sure you're on the right track there. In fact, when I was a Dataquest learner, I shared a project and someone pointed out that the way I had analyzed something was misleading. And it was very important for me to see that and then address it before I added it to my portfolio. What do I think of Advent of Code? I love Advent of Code. The 2-star days are so tricky sometimes. But yeah, really good way to practice. Going back to that earlier question of how to get good at Python. Advent of Code, Project Euler are both really fun programming language agnostic ways to practice some of these skills. Okay, I think I answered all of the questions and we are right on time. So questions, we did that. Thanks for coming. Yeah, I really appreciate everyone spending the time to join for the webinar today. This session will be, it was recorded and it will be shared with you via email tomorrow. And please do fill out the feedback survey. It helps to make sure that every project webinar are due, and we do them every couple weeks. Everyone is better than the last one. So it's quick, super quick to give feedback, so please do. And yes, thank you so much for coming, everyone. Yeah, thanks everybody in chat. Have a good day or evening, depending on where in the world you are.